This tour covers the liquid stream at the Las Vegas Water Pollution Control Facility. Collection system. Screening. Grit removal. Flocculation. Primary sedimentation. Nitrification, denitrification facility. Biological nutrient removal. Filtration facility. Disinfection. Discharge. Collection system. A maze of pipes collects wastewater from home appliances including clothes washers, dishwashers, kitchen sinks and disposals, toilets and bathtubs, and from businesses such as restaurants, hotels, casinos, hospitals, laundries, car washes, and other light industries to deliver influent to the Water Pollution Control Facility. Screening. Though this influent is 99% water, some debris also travels through the sewer and must be removed to protect equipment and the downstream process. To accomplish this, the WPCF plant process starts with the screenings facility. This facility removes debris, including cans, rags, branches, leaves, trash, and other miscellaneous large items, when the wastewater goes through one of 5 sets of fine screens. The fine screens capture the debris contained in the wastewater while allowing liquids to pass through and enter the treatment plant, like a strainer. Debris captured by the fine screens is washed and then loaded into a truck for disposal at landfill. Grit removal. The wastewater that passes through the screens still has very small debris like sand, gravel, and other material referred to as grit. If not removed, the grit could damage equipment, such as pumps, or settle out downstream and create clogs. The WPCF uses round grit removal chambers that spin the wastewater, creating a vortex that allows the small debris to separate from the wastewater. The sand and gravel is then washed and loaded into the same truck as the screenings and taken to a landfill. Flocculation. Ferric chloride is added to the wastewater at this point to aid the small particles in the water to settle. The iron salt grabs particles in the water and creates a clump. The clump is heavier than water and will tend to sink. Primary sedimentation. The wastewater and flocculants arrive at the primary sedimentation basin. Here, the water spreads out and slows down, like a stream flowing into a lake or pond. The slow-moving water allows the clumps of particles to settle to the bottom of the basin where it is scraped off and taken away. These clumps are now called sludge. The sludge is collected and moved to the solid side of the plant. Wastewater that leaves primary sedimentation is now about 80% cleaner than when it entered the WPCF, and can be pumped to the nitrification-denitrification facility or the biological nutrient removal basin. Nitrification-denitrification facility. Wastewater from the primary sedimentation basins is pumped into the nitrification-denitrification (NDN) facility basins where it is mixed with microorganisms and air. Think of it as a turbulent, tumbling stream. The microorganisms eat nutrients in the wastewater for their biological processes and to grow. These healthy, growing microorganisms collectively make up activated sludge. The activated sludge gets rid of much of the nutrients in the wastewater. After the NDN basin, the water and activated sludge flow into circular clarifiers, where the activated sludge settles to the bottom. This is because the microorganisms are full of nutrients and heavier than water. Some of the microorganisms are returned back into the NDN basins to breed more microorganisms. The rest is sent to the solid side of the plant. The result is very clear water that flows on to filtration. Biological nutrient removal. Biological nutrient removal, BNR, is an activated sludge process that operates in a similar manner to the NDN process, but goes further to remove more nutrients. The BNR microorganisms are subjected to different water conditions, lots of oxygen, little oxygen, and no oxygen, which enable them to serve multiple functions. These include the removal of phosphorus, organic material, ammonia, and nitrate. After the BNR basin, the water and activated sludge flow into circular clarifiers, where the activated sludge settles to the bottom because the microorganisms are full of nutrients and heavier than water. Some of the microorganisms are returned back into the BNR basins to breed more microorganisms. The rest are sent to the solid side of the plant. Like the NDN, the result is very clear water that flows on to filtration. Filtration facility. Clear water from the NDN and BNR is pumped into the filtration facility for filtering. Alum is added to assist in removing the remaining fine particles and phosphorus. In filtration, the water flows down through anthracite, a crushed coal product, fine sand, and gravel to capture solids, much like a sand swimming pool filter. Clean water flows on to disinfection. The captured fine particles are backwashed out of the filters and returned to the primaries for reprocessing. Disinfection. The filtered water is disinfected with sodium hypochlorite, extra strong bleach, in chlorine contact basins. This very lazy river ensures the bleach is in the water for at least 45 minutes. The concentrated bleach solution kills harmful microorganisms. Discharge. Water that will be reused on the plant or sold to golf courses is pumped away at this point. Water that will go into the Las Vegas wash and ultimately back to Lake Mead is dosed with sodium bisulfite to neutralize any remaining bleach. The entire process from collection to discharge is regulated by the Nevada Division of Environmental Protection, NDEP, and the Environmental Protection Agency, EPA, through the National Pollutant Discharge Elimination System, NPDES, permit, and Clean Water Act regulations.